What we're going to do is we're going to just quickly go through how this is set up. We haven't connected that yet. So if we go from this end, so this is where the power comes in. So let's have a look. So imagine we have a motor, and that motor generates electricity. The faster you pedal, the higher the voltage. And so this is a very unstable, unreliable power supply, meaning that it's continuously fluctuating. At the other end, we've got devices that that have a certain tolerance. So for example, I think this goes from 8 volts up to 36 volts. So if we put more than 36 volts into here, it's going to fry this component. This is basically just like a USB port. So we need some way to regulate it so that this doesn't fry. So this is just USB, whatever. So we can plug USBs into it. So this little box here is a buck converter. What it does is it can take in a variable amount of voltage, and what we can do is then set how much voltage it actually puts out at the other end. So this is a buck converter. So what we do is we put that buck converter into, or we put the output from the bike motor through this buck converter. So now we have a stable output, and that we can then just connect to our USB, and we know we have a safe supply. This particular motor is rated at most of the motors I've got are either 24 volts or 36 volts. And at 24 volts, I've tested this quite thoroughly. The maximum I can get to it by adjusting all the gearing, etc., is something like 42 volts. Now, most of the cheaper buck converters will only go up to 36 volts. So that's not good enough, that would blow. That's why I bought these ones, which go up to 60. So I know that this 36 volt one, I haven't tested well enough to know how much voltage I get. Obviously with the motor, it's designed that you put that voltage in, and having put that much voltage in, that's how much it will turn. It will turn the motor a certain number of times. I think in the case of most of the 24 volt ones I've got, it produces something like 350 watts at 24 volts, and it will turn the spindle 2,700 revolutions per minute. So that's what it's designed to do that way, but we've turned it the other way around. We're turning the spindle, and using different gearing we can vary how much pedaling we need to do in order to turn that spindle. And because we're varying the amount of times we're spinning it, it varies the amount of voltage. That's why we don't know. And as I say, with the 36 volts, I haven't done enough testing to know what the maximum I get. What I do also have is I have another one of these buck converters that goes up to 120 volts. So if for some reason these turn out to be way, I can generate more voltage than is necessary, I've got an alternative option. So the rest of these cables are all about just being able to see how much voltage and current I'm actually drawing from, and this is connected to, at the moment it's connected to what's coming out from here. So it's going to show us how much voltage do we have coming out from this converter, because this buck converter doesn't actually have a display on it. That's why I set it, so I can then adjust it to get it to the voltage that I want. But what is interesting is it will now show me also the current.